Hello, in this video I'll be explaining how we can use the FPGA board. In particular, we're going to use the Altera DE2-70 board. In this example, we will be controlling one of the LEDs on the FPGA board, which can summarize or give a brief on how the pin assignment works and how we can program the board. To start, we're going to create a new Quartus project by going to File, New Project Wizard, and then Next. I'm going to browse and select the location for my new project. I've already created a folder in the desktop which I called LED Controller. I will select that folder. And then for the project name, I will also be typing LED Controller. The file that I'm about to write will be controlling one of the LEDs on the FPGA board. Before we do that, we'll have to select the correct device name. Under the family, I'm going to select the Cyclone 2 family, and then under the name filter, I can paste the device name itself. Then I will select it, and after that we will click Finish. Now I'm going to create a new file by clicking on the new icon, and then I will choose VHDL file. This is the language that I will be using to write the VHDL code or to program the board. So I'll choose VHDL file. Then I will start with the library declarations. I will say library IEEE, use IEEE.standard logic. .all, and then use work.all. This line is optional in this case, we can remove it. Next, I'm going to create the entity part, or define the entity part of the code. I will call this entity LED controller, which is the same name as the project. Here we need to say is as part of the syntax, and then I'm going to end the entity. Since I will be writing code that can control one of the LEDs on the board, I will need for one of the ports to be called LED, for example, and this port is going to be an output port that is 1 bit of width. So I have a single output called LED, and it's 1 single bit. And in the end of this line, we need to add the semicolon as part of the syntax. To keep the example simple, I'm going to only have this one output called LED, which I'm going to assign the value 1 to it in the architecture part, which brings us to the last part of the code. So I will say architecture. For the name of the architecture, I will say behave, and then this behave architecture is describing describing the architecture of the LED controller. So we'll say architecture behave of LED controller is begin, and then end architecture. After begin, I will have to define the value of LED. So I will say LED is equal to, I will assign the value 1 to the LED port. Since LED is 1 single bit, I'm using the single quotation mark in this case. Next, I will select the entity name, and then go to File, Save, and then paste the name of the entity if it's not there already. Then click Save. And after that, we can compile the code to ensure that we don't have any errors in it. Now, after successful compilation, we can click OK, and then we can verify the schematic or the design by going to the Tools menu and selecting Netlist Viewers, RTL Viewer. This will show us the diagram or the block diagram of our code. We only have a single port called LED, and this LED port is connected directly to a logic high or logic 1, which verifies our design. We can now close this window and then go to the assignment menu and select pin planner. In this step, we will be assigning pins from the FPGA board directly to our ports in the code. Notice here I have only a single port called LED. These are all ports are listed under the node name, and then next to that we have the direction, which states whether the port is an input or an output, and then there's the location in which we're going to have to specify what pin on the FPGA board corresponds to that particular node or port. For me to choose one of the LEDs on the FPGA board, I need to look at the manual, and then we can press Ctrl F to search for the LEDs. LEDs on the FPGA board are two colors. We have the green LEDs on the right of the FPGA board. These are located above the push buttons or the keys. We also have red LEDs, which are located right above the switches or the toggle switches on the board. I will be trying to use this first LED, this first red LED on the FPGA board, and this is called LED R0. I will try to find LED R0 location from the manual, so I will be pressing Ctrl F. LED R will search for the red LED pin on the board. We can also add to it the square brackets towards the end with the name of the index needed. So for LED R0, this is the pin name I need to be using. I can select it, or can just type it from scratch. I will select it to be able to copy it in Quartus directly. Ctrl C to copy, and then go back to the pin planner, paste the pin name next or under the location next to the LED output. If we have more nodes or more ports, we're going to have to also decide on the location for each. In the next step, we're going to press on the Start I/O analysis, and then we will give it some time. After that, we'll click OK, and then in the same pin planner window, we will go to the File menu and select Export. This will allow us to export the pin assignment into a file that we can import later into our project. I will close the pin planner window and then go back to Quartus, go to the assignment menu and select Import Assignment. Click Browse and select what looks like a file that has the icon of an Excel file, because this is now a comma separated file. I will select it and then I will click OK to import the pin assignments that we just created. In the next step, we will compile our project once again and wait until compilation is successful. In the meantime, we can connect the USB port from the FPGA board to our desktop or computer to prepare for programming the board. Once compilation is successful, we can go to the Tools menu, Tools, and select the Programmer option. And then here we're going to click Add File and choose the output folder and select the SOF file, the LED controller.sof. Click Open. And then after importing or adding the SOF file, we will click Start, ensuring that USB cluster is selected. Now, after successful programming of the board, we will notice that LED 0 has been turned on based on the code that we wrote for it. And this is how we can control LEDs on the FPGA board. Now, to modify the code to make it more interesting, we can add an additional port that is an input port. We can call it control. This control input can be used to control the LED directly on the FPGA board using one of the switches. So this time we're going to add an input called control, and it's also one single bit, so we'll say underscore standard logic, and that's it. So under the port list, we have two ports, a variable or a port called control, that is an input, and it's 1 bit. And we also have an output port called LED, that is also 1 single bit. Now this time, instead of assigning 1 to the LED, we're going to say that LED is equal to control, where control is going to be one of the switches or toggle switches on the board, and LED is still going to be the same red LED on the board. Before we do the pin assignment, we will have to compile again. This will require us to or prompt us to save the file. We can click save and then wait until compilation is successful. Again, now that compilation is successful, we can verify the netlist viewer by going to verify the RTL viewer by going to Tools, Netlist Viewers, and select RTL viewer. We'll notice that this time we have two ports, the control input port and the output LED. We can close this window now, and we'll be going to the assignment menu and select pin planner to add the location, or to specify the location for the control port. Notice how now we have two nodes. First was the LED node, which we specified the location for earlier. And notice that the LED is an output, where the control is an input. We decided to use a switch to control the control bit. So for this, we're going to go to the manual and search for switches. Switches are abbreviated with the SW, and we will use SW0 for switch number 0, which is the first switch right below the first red LED. And we'll try to find the pin number for switch 0. And it turned out to be pin AA23. Instead of typing it, we can simply copy the pin name. And then Control V. Now, similarly, we will click Start I/O Assignment Analysis. In the pin planner window, we can export our pin assignment file by going to the File menu and choosing Export. Click Export. Now we'll click Close, and then back to Quartus. We can go to Assignment, Import Assignment, find or locate the LED controller assignment file and select Open. Click OK. Compile the file once again before programming the board. After successful compilation, we can go now to the Tools menu and select Programmer, and then ensure that USB Blaster is selected. Make sure the output file is chosen. If not, you can click Add Files and select it. And then click Start to start programming the FPGA board. Once the programming progress reaches 100%, we can move to the board and test it out. You can test this out on the FPGA board, and we notice that the LED is successfully turned on and the value of the switch is reflected on the LED. We can try now moving the switch back to 0 or low, and the LED will respond to the changes happening to switch 0.